All right, Honors Algebra 2, welcome back to the second video here. Had a little interruption there with my wife's work laptop. Anyway, where are we at? Oh, we were at 20, I believe. Okay, so if 4 to the third is 64, 4 to the negative third is 1 over 64. So 1/4 to the negative third would be 64 because a negative power will make this number that is less than 1 into a number bigger than 1. 4 to the third is 64. That one's one of the trickier ones on the page. 25 to the 1/2 power is x. X is 5. 36 to the negative 1/2 is x. So that means that's 1 over 36 to the 1/2. The square root of 36 is 6. 1 over 6 is x. X to the third is 8. X would be 2. X to the first is 17. X is 17. 20 to what power gives you 1? An exponent rule is anything to the 0 power is 1. X is 0. And 26, 4 to what power gives you 32? Again, it would be the same base. 2 to the second, 2 to the fifth. Multiply the powers, power to a power, with 2 to the second to the x power would be 2 to the 2x equals 2 to the fifth. X is 5 over 2. Solve for x, 27. Get them both be the same power. We literally just went over making 4 and 32 into base 2. Power to a power means you multiply. Set 2x minus 2 equal to 5. X is 7 over 2. All right. 28. 8 is 2 to the third. A power to a power means you're going to multiply the powers together. 3x plus 6. Multiply the powers together. 4x minus 4. 3x plus 6 equals 4x minus 4. On 29, 2x minus 6. 125 is 5 to the third, so 1 over 125 is 5 to the negative third. Set 2x minus 6 equal to negative 3. X is 3 over 2. 30. 9 is 3 squared. Of course, got to have another interruption here. Play circus. 1/3 is 3 to the negative first. So the bases are the same. I cut down a little work here. That means these exponents, 2x minus 6, would have to be equal to negative 1x. And, folks, that is wrong. Did you guys see where a boo-boo was made? It's definitely not that. Folks, you're going to subtract 2x from both sides. It's going to give you a negative 6 equals negative 3x. X is 2. X is 2. All right, not negative 6. Caught that one there. Power to a power, again, we're going to have here when we multiply, but gets 8 to be 2 to the third, get 32 to be 2 to the fifth. When we have a power to a power, we multiply. The bases are the same. The exponents must be equal. This must be equal to that. That is how, check my work, we should get a negative 7/8. All right, 3 to the negative third equals 3 to the fourth. Got a power to a power. Now the exponents are equal. 4x plus 12 equals negative 3. There you go. This is where it gets a little interesting. This is 2 to the third. Okay, I really can't do anything with 2 to the third. That's going to be what the base is. So 2 squared is 4. 3 squared is 9. So this is 2 to the third squared. Again, 2 squared is 4. 3 squared is 9. Okay, so then here's my power to a power. It's going to be 2/3 to the 4x minus 6 equals 2/3 to the x plus 1. Set those two equal to each other. X is 7/3. 34, if 100 equals 10 squared, then 1 over 100 equals 10 to the negative seconds. Set those exponents equal to each other. 35, 81 is 3 to the fourth. Set those exponents equal to each other. X is 8. On 36, 16 here is 4 squared. Power to a power. This is 4 to the 3x. 2x minus 6 equals 3x. Here, x is negative 6. All right. And This is just 2 to the 7th on the next one, so obviously I got to make 8 into 2 to what power? 2 to the 3rd, a power to a power, multiply them together. 3x minus 9 is 7. X is 16 over 3. And lastly, 9 is 3 squared. You got a power to a power. 27 is 3 to the 3rd, another power to a power, multiply those powers together. When the bases are equal, 3 and 3, set the exponents equal to each other. 2x minus 4 equals 3 minus 3x. 7 over 5 is your answer. Ooh, right. This page here is an interesting one. All right, maybe a little bit more of a challenge. What I want you guys to do, because you're going to do this in calculus with me one day, if you can't get them to be the same bases, I want you to attach natural log to both sides, or log. Natural log or log attached to both sides, because the power property says bring that down. That is a power. Then you would divide both sides by natural log 3. And then x plus 1 would equal natural log 6 divided by natural log 3. You would subtract 1 from both sides. And that would be your answer. That is an exact answer. Please leave your answers like that. So on 40, I can't get 13 to be 2 to any power. I'm going to attach natural log to both sides. That means x minus 4 is going to come on down. I will then divide both sides by natural log 2. Natural log 13 divided by natural log 2. I will then add 4 to both sides. All right. And get natural log 13 divided by natural log 2 plus 4. On 41, going to add 2 to both sides. Going to attach natural log to both sides. That means x plus 2 is going to come on down. Going to divide both sides by natural log 4. X plus 2 equals natural log 10 divided by natural log 4. Subtract 2 from both sides. Attach natural log to both sides. Bring down that exponent, x plus 5. Divide both sides by natural log 2. X plus 5 equals natural log 7 divided by natural log 2. Subtract 5 from both sides. 43. Attach natural log to both sides. Bring down this exponent. All right. Divide both sides by natural log 5. I think you guys get the point here. Holy cow, then I gotta add 1 to both sides. One step at a time. Then I'm gonna divide everything by 2. I know it looks weird, but that is it. Maybe there's a different way to write it. You can write natural log 7 divided by 2 natural log 5 plus a half. That's fine as well. That is good for now. On 44, add 1 to both sides. 3 to the 2x equals 5. Attach natural log to both sides. Bring down the power as I've done. Then you're going to divide both sides by natural log 3. So you have 2x equals natural log 5 divided by natural log 3. And then you're going to divide both sides by 2. Now when you divide by 2, 2 would go in the denominator. That's why it's right there. Some of you, if you look this one up, it might say natural log 5 divided by natural log 9 because that 2 can be written as an exponent. Same thing here. If you put the 2 there, it could be natural log 7 divided by natural log of 25, 5 squared plus 1/2. Anyway, many different ways to write that answer. Holy cow, look at 45. Attach natural log to both sides. There's no way to get 17 to be 3 to any power. Divide both sides by natural log 3. Okay. Subtract 1 from both sides. Subtract 1 minus 1. And then divide everything by 3. That is everything divided all by 3. That's one way to write our answer. And I can't get 17 to be